Let us start the panel discussion. Ubiquity of mathematics, the language of discovery. Over to you, Jennifer.
Thank you so much. Thank you. Good evening. Before we start, I just want to very quickly to thank this amazing family, Hanlong family, Ronnie, Adriel, and the Hanlong Group. You are doing so much for Hong Kong community and for our youth, and bring everybody together, create such opportunity, and also be role model for the business community. Thank you so much. The two professors sitting besides me, I do a lot of public speaking, but this is the highest average IQ I can achieve on stage. After tonight, it's all downhill for me, but the two professors obviously have very distinguished career, true visionaries and legends, and their bio is available on the booklet. I won't repeat, but something you don't know from the bio is that Professor Sheng, you're one of the 13 kids in your family, and neither your parents were mathematicians. We often hear this debate, math is a genetic gift. You either have it or you don't. So how did you become a mathematician? How did you train yourself? What's your journey?
Well, I do have a very unusual family background. Neither of my parents finished high school, and as Jen said, I'm one of 13 children, and I'm number 10. I'm the 10th child, and so when I was about age 13, one of my older brothers had gone to university and majored in math and finished college, and he became a high school teacher for a few years. Eventually, he went back to graduate school and got his PhD in mathematics education. But at that time, he encouraged me a lot and brought me books, and so I learned how to read mathematics books, and I really enjoyed the problem-solving aspects of it. And so I just, from that time on, was really focused primarily on math. And I also had another older brother who was starting college when I was 13. He also became a math major and eventually a math PhD. So in my family, I'm the third math PhD. But I should say that part is very unusual, but my background also includes some things which I think are very relevant to the students here. One thing is when I got into high school, I got a lot of encouragement from my math and physics teachers, and that was really a very helpful thing for me as well. And so I was very lucky, both family-wise and with the high school teachers. But another bit of luck I had was I happened to grow up or be a teenager in a very special era in the United States, which was the 1960s, which was the Sputnik era. So it was the time when the United States was competing with the Soviet Union to put a man on the moon. And so in the U.S., there was a big push toward math and science education. So it was highly respected in society and even fashionable somewhat to be a mathematician. So I think that was also a factor in my choice to do math as well. And I think it's interesting to compare that to today, because I see that sort of push going on in China these days. And in particular, this math competition is really shows that math and science education is important to the public and also the business community in Hong Kong. So I think that's a really important thing, and it sort of does reflect my own experience to some extent.
You didn't answer me. Do you think math is a muscle you can exercise, or do you think it's a genetic gift, or both?
Well, I think that people have a certain ability, but I think no matter how much ability you have, you won't become a mathematician without really being focused and working hard on it. So whereas if you have less ability and you work and you're really interested and you focus hard, I think you can beat out people with much more ability than you mathematically. Math is a long game. I mean, a lot of the so some math competitions involve rather short-term problems like the Math Olympiad. So the ability to do those doesn't necessarily correlate with becoming a good mathematician.
100%. Professor Mark, something is also not in your bio. I don't know how many of you know, obviously brilliant mathematician, scientist, but also you're extreme polyglossia. That's a fancy term to say that you're very cunning linguistic. How many languages do you speak?
Well, I set a high standard for learning something. If you ask whether I can give a lecture in the language, I think I can do it in 6 or 7. Yeah.
Only 6 and 7 languages. Which are they?
But I can learn Chinese and Mandarin, Cantonese, English, French, German, Italian. I know some Japanese.
You speak some Russian as well.
I manage. So there are things that I can understand or I can read, and like Spanish and Portuguese. Yeah.
So beyond pattern recognition and symmetries, what do you see that's consistent, in the beauty? We often say beauty in mathematics, right? What do you see this kind of, poetry, language, and mathematics have in common in the sense of beauty?
Well, in the sense of beauty, should I say, let me introduce a little bit why I was interested in these things. Well, as a child, I was very curious, and I want to understand how the brain functions. So in primary school, I was very good in mathematics, so I had that ability already. But I thought that just being good in mathematics is not good enough. So everybody communicates in the language. So I want to understand how language came to exist. So then in Hong Kong, I speak Cantonese as a dialect. In school, I read classical Chinese, and I was very interested in poetry and so on. So I came to try to understand the world through the software of language, if you may. At that time, there's no such vocabulary as a software. So I saw, as a child, how different Chinese and English is. So how come that there are such different languages? And so I tried to understand the structure of languages. And then, but language by itself, with its grammatical rules and all that, is dry. So in order to access language, I have to do it through literature. And as a child, already in primary school, as a lover of poetry. My teachers never taught me how to write classical poetry, as only to appreciate it. So I learned the rhythm. I learned to recite poems and so on. So I was in a team which does this with a mathematics teacher, actually. So then I find in all of these aspects of my knowledge, of my basic knowledge, mathematics, poetry, and linguistics, the common feature of having very rich structure. So I particularly prefer classical Chinese poetry. I don't have a very good memory. Yeah, I'm just like everybody. And in order to maintain or remember something, I have to look at things that have more pattern in it. And classical Chinese poetry imposes certain symmetry or duality. So then there's a structure in this Tang poetry where the structure is in some sense defined. There are couplets inside, and then there are oppositions of tones. And then there are also the very intricate structure, and can see the sort of a structuralism embedded in Chinese poetry, which is suitable for me. So then when I first wrote poetry, I only wrote poetry very late, because my teacher in school didn't tell me that I could write. So the moment I tried to write, I realized that I could write. So then I got so attracted by it that for a couple of years I was writing every week. And then it seems like that I have a lot of things I wanted to say, and was in the most compact language I could express it in poetry. Now, and I should tell you that somebody with a mathematical mind is better suited to understand, appreciate, and learn Chinese linguistics and also Chinese poetry. And certainly that was my experience. I make use of my mathematical mind to do it. I was writing things at a time when AI was not there. And I not only wrote Chinese poetry, I also tried poetry in other languages. So then, of course, I have to learn, and this gives me some circumstances to deepen my knowledge of the language. So each language has its own each poetry of different languages. They have their characteristics. So you have to learn the pattern, the style, and also the flavor, and all this involves aesthetics. So in that sense, but then it's not just pattern recognition, it's the whole structure. And then you have to look at things globally, historically, and these are subjects which have long history, like mathematics coming, of course, there are very old Chinese mathematics, but from the Greeks. And then, of course, linguistics. I was at one point interested in Sanskrit. I wanted to understand the classical languages and so on. So all these things are things with depth. So, and this depth is reflected by a very rich structure. And then I learn the structure, and I learn everything by learning its structure, so including other things like I was interested in the sociology, for instance. Actually, in my bachelor year, undergraduate years, I only took social science, history, and literature from the undergraduate curriculum. I didn't take any mathematics except for one course in set theory, second order logic, and that was from the Department of Philosophy.
So I think if you're feeling like you're underachieving your life, you're not alone. I'm feeling underachieving. So Professor Sheng, for the youth today, if they're not learning 7 languages and classic Chinese poetries and teaching Russian, what should the students today study to be more capable in the AI world?
Okay, so I should first say that I'm not an expert in AI. I'm speaking as a mathematician who just knows a little bit about it. But my feeling is that the subject is changing very quickly, and if you try immediately to learn AI at this point, by the time you learn it, your knowledge might be outdated. So I think it would be wise for a student to develop a solid core in mathematics. So so mathematics is sort of divided into algebra and analysis, and the two subjects both involve reasoning and problem solving, but of a little bit different form. And so I think flexible thinking, so learning how to reason and solve, and also to isolate the fundamentals of a problem. I think the great thing about mathematics is you can take a problem with lots of words, lots of complicated things, and a mathematician can realize, well, what's really involved here is just something we can model rather simply. And so the ability to model and solve problems in that way, I think, is something you learn by learning core mathematics. So I would suggest that. In terms of subjects which actually will be important for AI, of course, you should learn discrete math, probability, statistics, and of course, programming. Computer programming will be important too. So that's my opinion.
So right now, we are living in a world that AI is playing a very big role in terms of our work and research. Where is the future of mathematical research in the AI world?
Well, there are different opinions on this, but certainly it serves as a good assistant. Now, people are trying to push the frontier of application of AI to mathematics. So, like proof checking. So there is there's Lean. Now many people learn it and make use of that to check the validity of proofs that have been written in literature. So we keep a very rich literature, the journals and so on, for 200 years or something. But especially in recent years, with the explosion of publishing, there's no guarantee that what you see is rigorous. It's completely rigorous. Of course, mathematicians are already those who keep a highest rigor, but nonetheless, there might still be mistakes. So now we're making use of AI, and my colleagues are doing it to check proofs. And then when they find the gaps in the proofs, also when this is just some minor things, it also try to patch it. At least they identify the problem. So far, I have not heard a major theorem being checked to be to have a wrong proof. That cannot be patched. I have not heard that. There may be, I do not know. But they are doing big projects, even to check Fermat conjecture and things like that. So that's one aspect. The other thing is that, of course, but the layman, the public, doesn't understand the nature of AI. It's probabilistic. It's also, in some sense, a guessing machine, right? The large language model. So it's statistic. It's unlike human language. There's a human language, of course, you have phonology, you have morphology, you have semantics. And for the large language model, the major actor, as I was told, was the vector. So this is statistics. So taking long chain of digits and representing some text, right? So then you have various ways to ask the AI to sort of optimize your guess so that you would make a meaningful sentence, but whether this is the correct sentence is well, not so clear. So you can, if you tell the layman may believe that AI is always generating the truth, which is not the case. So they need to be educated that it is a highly faithful guessing machine for certain things. But for certain other things, it might be completely off the mark. So you could, with the existing like ChatGPT or other AI machines, you can ask questions for which they produce answers which look like correct. But because they use a vocabulary that is often appearing in an answer and the correct answer to that, but they might do combinatorics which make the sentence either not meaningful or incorrect or not precise, right? So then there's much to be improved. I don't know whether large language model is the ultimate thing. Maybe there are other means to improve upon it. And also there's the fact that whereas the machine is actually solving problems by very often by brute force. So this involves a lot of calculations and therefore the use of energy. And there may be, as things are multiplying exponentially and so on, there might be a point when such a means of doing this is no longer feasible. So then the mathematics enters in a major way. I think it will enter in a way that's more and more important in the sense that we have to find solutions that are economical. So people have been comparing the human mind with AI and saying that we're overtaken by AI. So I do not side with that remark. It's in our hands. We should be the ones who sort of let this revolutionary discovery meander in the proper way so that we can harness its power, but on the other hand, not be overwhelmed by it. So how can we do it is a major problem. Right?
So human in the loop, machine-human symbiosis, but human should drive it.
Yes, that's what I think.
I think we're almost out of time, but I'll leave the last question. I'll combine the two questions. Eugene Wigler argued this unreasonable effectiveness between math and natural science. When math describing the world, somehow you think math is somehow we created it, but it fits everything in nature. So do you think math is observed or created, discovered? And because there's so many things that kind of just fit into math, do you think God is a mathematician with OCD?
Well, unfortunately, I'd like to answer the question, but we've run out of time.
I think we have 1 minute. Okay. 1 minute answer, please.
Well, it's a very philosophical question. Of course, there are different views on it, but my feeling is that most important subjects in mathematics arise from the real world. So they may not be problems that people would care about solving, but nonetheless, they're real world problems. And so mathematicians then would generalize and abstract those. And so the fact that, and do it in such a way that it's it's very natural from a mental point of view. I mean, it's natural, logically very natural. And so the fact that some of those generalizations would then apply back to the real world seems to me to be not that surprising. And so you can see that in certain cases, like in relativity, the invention of Riemannian geometry was not, I mean, it was really based on the
Somebody
real world.
made the rule.
But yeah, it's a real world thing. I mean, Riemann was motivated by real world things. Then it turned out later to be important in physics and general relativity. And there are other examples like that too. I mean, even group theory, of course, is a very physical, real world thing, and which has had lots of applications.
I think we can talk about this all night long, but thank you so much, Professor Shan. Ladies and gentlemen, Professor Mok and Professor Shan. Thank you.
Thank you for a very stimulating panel discussion.